In commercial buildings, separating lighting and receptacle circuits is generally considered a good practice and often required by building codes. The National Electrical Code, referred to as NEC, recommends separating these circuits to prevent nuisance tripping of circuit breakers due to harmonic currents and voltage fluctuations. Electronic devices, including computers, generate harmonic currents. These currents can interfere with other electrical equipment and cause problems such as voltage fluctuations, overheating, reduced equipment lifespan, and data loss. By separating lighting and receptacle circuits, the harmonic currents from lighting loads are isolated from sensitive electronic equipment plugged into receptacles, which helps to mitigate potential interference issues. Separating lighting and receptacle circuits also has practical benefits. Firstly, easier troubleshooting occurs because if a circuit breaker trips, it is easier to identify the source of the problem if the lighting and receptacles are on separate circuits. Secondly, reduced downtime will occur because if a circuit breaker trips, only the affected area will be impacted, rather than the entire office. Thirdly, energy efficiency can improve, since lighting loads can be significant in commercial buildings, and by separating lighting circuits, it is possible to implement lighting control strategies that can reduce energy consumption. Based on industry standards, building codes, and practical considerations, it is generally recommended to separate lighting and receptacle circuits in commercial offices. This helps to mitigate potential interference issues from harmonic currents, improve troubleshooting, reduce downtime, and enhance energy efficiency. The NEC provides guidelines for electrical installations, and many local building codes adopt or adapt these guidelines. Therefore, it is crucial to consult the specific codes applicable in the area. When designing electrical systems for commercial buildings, it is necessary to consider the potential impact of harmonic currents. Nonlinear loads such as electronic devices, LED lighting, and variable frequency drives generate harmonic currents that can distort the voltage waveform and cause various problems. Firstly, overheating of electrical equipment can occur, including transformers, conductors, and motors. Secondly, increased energy losses may result. Thirdly, malfunctioning of sensitive electronic equipment could happen. And fourthly, nuisance tripping of circuit breakers is possible. To mitigate these issues, several strategies can be employed, including, firstly, separating lighting and receptacle circuits. Secondly, using harmonic filters to reduce harmonic currents. Thirdly, oversizing neutral conductors to accommodate harmonic currents. And fourthly, using transformers designed to handle harmonic loads. The NEC addresses harmonic currents in several sections. Section 220.61 covers the sizing of neutral conductors for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and electric dryers, taking into account the nonlinear loads that generate harmonic currents. Section 310.15 addresses the ampacity of conductors and provides adjustment factors for harmonic currents. Section 450.3 covers the protection of transformers and addresses the impact of harmonic currents on transformer overheating. When designing electrical systems, it is essential to consider the specific requirements of the building and the types of equipment that will be used. For example, if the building will house a data center or other sensitive electronic equipment, it is crucial to implement measures to mitigate harmonic currents. Similarly, if the building will use a large number of LED lights, it is important to consider the impact of harmonic currents on the electrical system. A well-designed electrical system should minimize the generation and propagation of harmonic currents, and it should protect electrical equipment from the harmful effects of these currents. Separating lighting and receptacle circuits is a fundamental step in achieving these goals. Lighting control strategies can further enhance energy efficiency in commercial buildings. These strategies include occupancy sensors that turn lights off when a space is unoccupied, daylight harvesting that adjusts lighting levels based on the amount of natural light available, and dimming systems that allow lighting levels to be adjusted to suit the needs of the occupants. By implementing these strategies, it is possible to significantly reduce energy consumption and save money on electricity bills. Moreover, regular maintenance of electrical systems is essential to ensure their safe and efficient operation. This includes inspecting and testing circuit breakers, conductors, and other electrical equipment, as well as cleaning lighting fixtures and replacing lamps. Proper maintenance can prevent electrical failures, reduce downtime, and extend the lifespan of electrical equipment. In conclusion, separating lighting and receptacle circuits is a crucial aspect of electrical design in commercial buildings. It helps to mitigate harmonic interference, simplifies troubleshooting, enhances energy efficiency, and improves the overall reliability of the electrical system. By following industry standards, adhering to building codes, and implementing appropriate mitigation strategies, it is possible to create a safe, efficient, and reliable electrical system for any commercial building. Furthermore, it is important to stay up to date with the latest developments in electrical technology and to continuously improve electrical design practices. This will ensure that electrical systems are able to meet the evolving needs of commercial buildings and that they contribute to a sustainable future. In addition to separating lighting and receptacle circuits, there are other best practices that can be followed to improve the performance of electrical systems in commercial buildings. Firstly, use high-quality electrical equipment, as high-quality circuit breakers, conductors, and other electrical equipment are more reliable and less likely to fail. Secondly, properly size electrical equipment, as correctly sized electrical equipment is able to handle the loads placed on it without overheating or malfunctioning. Thirdly, install surge protection devices, which can protect sensitive electronic equipment from voltage surges. Fourthly, ground electrical systems properly, and this ensures that electrical systems are properly grounded to prevent electrical shocks. Fifthly, regularly inspect and maintain electrical systems, which can prevent electrical failures and extend the lifespan of electrical equipment. By following these best practices, it is possible to create electrical systems that are safe, efficient, and reliable. In addition to the NEC, other standards and guidelines may be relevant to electrical design in commercial buildings. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, referred to as IEE, the National Fire Protection Association, referred to as NFPA, and the American National Standards Institute, referred to as ANSI. These standards provide guidance on various aspects of electrical design, including grounding, bonding, surge protection, and harmonic mitigation. It is important to be familiar with these standards and to follow them when designing electrical systems. The design of electrical systems in commercial buildings should be a collaborative process involving electrical engineers, architects, and building owners. By working together, it is possible to create electrical systems that meet the needs of all stakeholders and that contribute to the success of the building. The electrical engineer is responsible for designing the electrical system and for ensuring that it meets all applicable codes and standards. The architect is responsible for integrating the electrical system into the overall building design. The building owner is responsible for providing input on the needs of the building and for approving the final electrical design. By collaborating effectively, these stakeholders can ensure that the electrical system is safe, efficient, and reliable. When designing electrical systems for commercial buildings, it is important to consider the future needs of the building. The electrical system should be designed to accommodate future growth and changes in technology. This may involve oversizing electrical panels, installing additional conduit, and providing for future expansion of the electrical system. By planning for the future, it is possible to avoid costly and disruptive electrical upgrades later on. The separation of lighting and receptacle circuits is particularly important in areas where sensitive electronic equipment is used, such as data centers, hospitals, and laboratories. In these areas, harmonic currents can cause significant problems, including data loss, equipment malfunction, and downtime. By separating lighting and receptacle circuits, it is possible to minimize the impact of harmonic currents on sensitive electronic equipment. Furthermore, in areas where flammable materials are present, it is important to take extra precautions to prevent electrical fires. This may involve using explosion-proof electrical equipment, installing fire-resistant wiring, and implementing fire suppression systems. By taking these precautions, it is possible to minimize the risk of electrical fires and to protect people and property. The electrical system is a critical component of any commercial building, and it is essential to design and maintain it properly. By following industry standards, adhering to building codes, and implementing appropriate mitigation strategies, it is possible to create a safe, efficient, and reliable electrical system that meets the needs of the building and its occupants. It's also crucial to consider the specific type of lighting being used. Traditional incandescent lighting produces minimal harmonics, while newer technologies like LED and compact fluorescent lamps, or CFLs, can generate significant harmonic distortion. This is due to the electronic ballast or drivers used in these energy-efficient lighting systems. Therefore, the need for separation becomes even more critical when using these types of lighting. When retrofitting older commercial buildings with new lighting systems, it's important to assess the existing electrical infrastructure to ensure it can handle the increased harmonic load. This may involve upgrading the neutral conductor, installing harmonic filters, or implementing other mitigation measures. In some cases, it may be necessary to replace the entire electrical panel to accommodate the new lighting system. The location of the receptacle outlets is also a factor to consider when deciding whether to separate lighting and receptacle circuits. Receptacles that are located near sensitive electronic equipment, such as computers or medical devices, should be on separate circuits from lighting to minimize the risk of interference. Receptacles that are used for general-purpose applications, such as powering office equipment or appliances, may be on the same circuit as lighting, but it's still recommended to separate them if possible. The use of uninterruptible power supplies, or UPS systems, can also help to protect sensitive electronic equipment from voltage fluctuations and power outages. UPS systems provide a backup power source that can keep equipment running during a power outage, and they also filter out voltage fluctuations and harmonic distortion. UPS systems are commonly used in data centers, hospitals, and other critical facilities where downtime is unacceptable. In addition to the technical considerations, there are also cost considerations to keep in mind when deciding whether to separate lighting and receptacle circuits. Separating the circuits will require more wiring, more circuit breakers, and more labor, which will increase the overall cost of the electrical installation. However, the long-term benefits of separating the circuits, such as reduced downtime and improved energy efficiency, may outweigh the initial cost. Ultimately, the decision of whether to separate lighting and receptacle circuits is a complex one that depends on a variety of factors. It's important to carefully consider all of these factors before making a decision. Consulting with a qualified electrical engineer or contractor is highly recommended to ensure that the electrical system is designed and installed correctly. Another aspect to consider is the potential for future expansion or modification of the electrical system. If the building is likely to undergo renovations or additions in the future, it's important to design the electrical system with flexibility in mind. This may involve installing extra conduit, providing additional circuit breakers, or oversizing the electrical panel. By planning for the future, it's possible to avoid costly and disruptive electrical upgrades later on. Regular inspections and testing of the electrical system are essential to ensure its continued safe and efficient operation. Inspections should be performed by a qualified electrician, and they should include a visual inspection of the wiring, circuit breakers, and other electrical equipment. Testing should include checking the voltage, current, and resistance of the circuits, as well as testing the operation of the ground fault circuit interrupters, referred to as GFCIs, and arc fault circuit interrupters, referred to as FCIs. Any problems that are identified during the inspection or testing should be repaired promptly. The electrical system is a complex and critical part of any commercial building. It's important to design, install, and maintain it properly to ensure its safe, efficient, and reliable operation. By following industry standards, adhering to building codes, and implementing appropriate mitigation strategies, it's possible to create an electrical system that meets the needs of the building and its occupants for years to come. When considering energy efficiency, it is useful to remember that lighting controls can significantly reduce energy consumption. These controls include occupancy sensors, daylight harvesting systems, and dimming systems. Occupancy sensors detect when a space is unoccupied and automatically turn off the lights. Daylight harvesting systems adjust lighting levels based on the amount of natural light available, reducing the need for artificial lighting. Dimming systems allow occupants to adjust lighting levels to suit their needs, providing further energy savings. Furthermore, regular maintenance of lighting systems can improve their efficiency. This includes cleaning lighting fixtures, replacing old lamps with energy-efficient models, and ensuring that lighting controls are functioning properly. By implementing these measures, it is possible to significantly reduce energy consumption and lower electricity bills. In conclusion, the separation of lighting and receptacle circuits in commercial buildings is a crucial aspect of electrical design that offers numerous benefits. It mitigates harmonic interference, simplifies troubleshooting, enhances energy efficiency, and improves overall reliability. By adhering to industry standards, complying with building codes, and implementing appropriate mitigation strategies, a safe, efficient, and dependable electrical system can be established, meeting the demands of the building and its occupants. Remaining current with the latest advancements in electrical technology and continuously refining electrical design practices is essential to ensure that electrical systems cater to the evolving requirements of commercial buildings and contribute to a sustainable future. It's also worth noting that some jurisdictions may have specific requirements regarding the separation of lighting and receptacle circuits. It's important to check with the local building department or electrical inspector to ensure compliance with all applicable codes and regulations. In addition to the technical aspects of separating lighting and receptacle circuits, there are also some practical considerations to keep in mind. For example, it's important to label the circuits clearly so that occupants can easily identify which circuits control which lights and receptacles. This can be helpful when troubleshooting electrical problems or when performing maintenance on the electrical system. It's also important to provide adequate access to the electrical panels so that electricians can easily perform inspections and repairs. The electrical panel should be located in a well-lit and easily accessible area. It should also be kept free of obstructions so that electricians can work safely. The choice of wiring method can also affect the performance of the electrical system. Conduit is a common wiring method in commercial buildings, and it provides excellent protection for the wiring. Cable is another common wiring method, but it's not as well protected as conduit. When choosing a wiring method, it's important to consider the environment in which the wiring will be installed. In wet or damp locations, it's important to use a wiring method that is suitable for wet locations. In areas where the wiring is subject to physical damage, it's important to use a wiring method that is well protected. Grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. Bonding connects all of the metal parts of the electrical system together, which helps to prevent voltage differences from developing between the metal parts. It's important to ground and bond the electrical system properly to ensure electrical safety. Surge protection is another important aspect of electrical safety. Surge protection devices, or SPDs, protect sensitive electronic equipment from voltage surges, which can damage or destroy the equipment. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. It's important to install SPD at the electrical panel and at any sensitive electronic equipment. Electrical safety is paramount in commercial buildings. It's important to take all necessary precautions to prevent electrical shocks, fires, and other electrical hazards. By following industry standards, adhering to building codes, and implementing appropriate safety measures, it's possible to create a safe and reliable electrical system for any commercial building.